This is day 1 notes for unit number 3, chapter 7 through 9. Describing bivariate data with scatter plots. The first step when analyzing a relationship between two quantitative variables, i.e. numerical stuff, things that are counting, is to graph using the data using a scatter plot. In a scatter plot, the explanatory variable, and remember that's the one where we think it's causing something to happen, should be on the x-axis, and the response variable should be on the y-axis. The explanatory variable seeks to explain or predict changes in the response variable, and that's important enough that I'm going to highlight that for you. Usually, the explanatory variable comes first chronologically. For example, when comparing SAT scores and college GPA, SAT would be the explanatory variable since colleges use it to make predictions about how successful students will be in college. Each axis should be clearly labeled with the variable's name and unit. It should also have a well-marked and uniform scale on the axis. However, the scales do not need to be the same, i.e. the X could have a wider space between the tick marks than the Y. The axes often intersect at 0, 0, but this can change depending on the range of the data sets. Patterns are more visible when there is less empty space and the data is more spread out. Okay, we have 4 key features of scatter plots. However, I'm going to stop you and say, look up the 4. Sorry, let me say that again. I'm going to stop you before I tell you the 4 key features of a scatter plot. I'm going to ask you to look up the 4 features of a distribution from earlier chapters that'll help you on the warm-up next time. Alright, but the new thing is there are also 4 key features of a scatter plot, and they are direction, form, strength, and unusual values. Okay, number 1 for direction, there is a positive association, i.e. higher values of one variable are associated with higher values of another. For example, maybe it's weight, okay, and height. If this is height, okay, the taller you are, the more you tend to weigh. Now that's not always the case. You could be really, really tall, but super skinny and you'd be down here, okay? But in general, there tends to be a pattern there. There are also negative associations, where the higher value of one variable is associated with the lower value of the other variable. So for example, let's say hours playing video games okay, and maybe those hours are taking up your time to study. Well, the more hours you play, the lower your grade may be. Okay, so you spent the whole weekend and all of fall break playing video games and not studying, well then yeah, your grade's going to be pretty low. Okay. Lastly, there just may be no association. Higher values of one variable do not give any information about the value of other variables. In other words, the two variables are independent. And there's lots of stuff like that. Okay, kind of a crazy example for no association could be something like, the more you study, you might guess and say, the more you study, the more likely it is you have green hair. Okay, we know that that's not the case. You might have green hair because you have husky pride, but that's not going to have to go along with how much you study. The second thing we look at for scatter plot are form. Okay, is it linear? I.e., if you kind of connect the dots, does it make a line? Is it exponential? And actually, that one is not exponential. That is logarithmic. And that's because they're inverses, and so I got confused. Okay, it could possibly be quadratic. So the points kind of form a quadratic shape or parabola, or it could be exponential. And that might be something like, you know, zombie infection. It starts out slow. This is your time. At first, just 1 or 2 people are infected, but as time goes on, the zombies bite more and more people, and more people are infected. Okay, and then the last one is strength, and we measure that with an R and an R squared value. Okay, and we will talk about those later. So we're going to skip 3 and go on to 4, which is unusual values, which you're used to, and those are outliers. Outliers are values that fall outside the pattern of the rest of the data. Sorry to repeat. Outliers are values that fall outside the pattern of the rest of the data, and clusters of points that are isolated from the rest of the data. We always want to investigate these values because sometimes it could be where you did something wrong, but oftentimes it's where the most interesting things are happening. Okay, so what I have here are some scatter plots from McDonald's Nutrition Facts, and they actually do come from the McDonald's Nutrition Facts, although they're about 7 or 8 years old. McDonald's hasn't changed its menu that much. Okay, if you think about it, if we're looking at just beef, okay, we're listing all the fat and the different types of beef products that McDonald's has. Well, obviously, the more fat it has, it seems that that product will also have more calories. So this would be a positive association. I'm just going to say PA, and it's kind of linear. And so actually, we could say positive correlation if it's linear. We'll talk about that later. Okay, this next one, we're looking at sodium in their salads, okay, and the amount of fat. And instead what we have is some clusters, okay? So it has kind of lower sodium. And then these two both have higher sodium, but they're clustered as far as the amount of fat. Well, if you think about it, think about the type of salads that they have. They have just garden salads or salads with meat. Maybe this has lower sodium and lower fat, and maybe this is a no meat salad. Okay, and often people that do the no meat, they may also do the lower dressing, the lower fat dressing. Okay, now these two very probably have meat, but what would be the difference in the fat? Maybe how the meat is prepared. So this would be grilled chicken or whatever. Okay, they usually do chicken versus fried. So again, the clusters tell us something. I don't see a nice line going through it, so there's no correlation, but there still is an association in the way that they are presented. Okay, then this last one is beverage. Okay, and we have, it almost appears to have 2 sets of data. We have this data over here, but if you look very carefully, we also have this data. Well, let's think about the type of beverages they serve at McDonald's. Okay, they have soda, they also have shakes, okay, juice, water, tea, okay, and we're looking at the fat content to calories. Well, maybe this green line could be their diet sodas. Okay, they also have iced tea that's unsweetened. It could be juice, but juice tends to have a lot of calories if there's sugar. Here though, then, we're looking at fat. Okay, maybe we've got regular sodas, and then we're starting over here at the shakes. So again, we kind of have a loose linear trend here and something else here. So these scatter plots really do help you pick out what's going on. Okay, so we skipped 3, which was how we discussed the strength of the correlation. And when I said R and R squared, and we're going to talk about the first one, which is R, and that is the correlation coefficient. It is a numerical way to help us identify the amount of scatter in a scatter plot, and it's calculated using the correlation coefficient. You need to memorize this. Okay, correlation coefficient, I'm going to do it in red, is just R. And it measures the strength of the linear relationship between two quantitative variables. Denoted R, it will always be between -1 and 1. And here are some examples, okay? So if you look at this one, it's almost a perfect line, and it's positive. So the R is a positive number really close to 1. This one, it could maybe be going up, but there's lots and lots of scatter. So notice that it's still a positive number, but it's much closer to 0. And 0, an R of 0, means no association. Or no linear association. I should say no correlation. Because this is looking at linear stuff. All right. So then this one here, we have an R of 0.01 that's really close to 0. Notice the data is super scattered, right? So this is pretty much no correlation. And I'm going to start using the word correlation. Correlation goes with R. It's when we're talking about if there's a line. Okay, then maybe this has some other type of association, but it doesn't have a correlation. And then this one also is a line, but it's going the other direction, more negative. Notice it's not quite as squished together and less scattered as here. Okay, so this one has a fairly strong negative correlation. That's why it's 0.9. Okay. If we wanted to think about this, I'm going to go back up here. R equals 0, we said is none. R equals 1 is a perfect positive correlation. And R equals -1 is a perfect negative correlation. Okay, and we'll look at some more of those. All right, there are ways to calculate R. Calculating the scatter plot showing calories versus fat for the beef products at McDonald's, there seems to be a very strong association, so the correlation would be very close to 1. Notice I could draw on a line. How does the relationship change if we standardize both variables? I.e., we found the z-score. It's haunting you. It's not going away. Okay, so what I'm doing is I can tell you that there was this point right here that is 9 and 250. Okay, so we have the point 9, 250. All right, this is the x and this is the y. Well, if we're going to standardize it, we'd put the 9 right here. This is the average x's out of that whole graph, and this is the standard deviation of that whole graph. Again, it's the beef graph, okay? So I had the raw data and found the average and the standard deviation. And then according to the y's, this was the average, and what was our y here? Fat content? Oh, average calorie content. Okay, with the standard deviation. So this one again was fat, and this was cal. All right, so we're going to plug in the x's and the y. And if we do that, this has a standard deviation. Okay, if we went ahead and did this in our calculator, we get about -1.56, or a z-score of -1.6. And it turns out, and it's just coincidence, that we get approximately the same